In this YouTube tutorial, I am going to teach you how to download SRTM DM from USGS website, and if you don't have your watershed shapefile, and how to prepare it using SRTM DM. So this is the main basic thing that you need in order to do the project. You need watershed shapefile. If you don't have it, we can prepare it on your own. Follow my YouTube tutorial. So first we will go to USGS website, and USGS Earth Explorer website. So after that, you have to log in using your credential. It's free of cost. So if you don't have an account, please create one. I think okay. Now after this, you should for example, I am doing it for Hemavati catchment. Now download some PDF or literature work or any other scientific paper published on this Hemavati catchment, and know your boundary. For example, I'm in this YouTube tutorial I will be showing for Hemavati catchment, but for Rispana river I have downloaded a PDF. I will be showing it to you and giving you an idea on how to prepare these things. So I have downloaded this PDF for Rispana catchment. You can see here. So there is no rocket science here. Go to Google and type something like Rispana catchment scientific paper PDF, something like that. You will get some PDF. So by looking at this, you know what are the bounds of your Rispana river or catchment. See here, it is in the four corners of this map should be noted down. So this map, four corners, XY, 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 and XY. Like that, you should note it down, and note it down using a pen and paper. Since it was in meters, you go through the PDF as usual, and you look at here. So I got the catchments, one more map, and note this corner. This is 78 degree 0 minutes 0 seconds. So this point will be some so this point will be by approximately I'm saying this point will be 77.5 degree. That means 77 degree 30 minutes, and its y coordinate will be same. Y coordinate will be this 30 plus something. For example, it's 30, say 30 degree 31 minutes. So this is approximate. You have to have these four corners. I will also show you something just similar to that. Here surface hydrology, and I will show you. So you have to have this so these are the, so I will be generating this catchment shape file. This is for some other river. I'll be generating this. So my four corners are, now this corner is 13.5 and 77.5. This corner is again 13.5 remains constant, and 76.5. The four corners you have to note it down. Note it down using a pen and paper, or else I will show you here only. Draw. So okay, I'm able to write now. So I will show it here. This is the x coordinate. So it's 75.5. These are the work I have done. So these are the corners of my DM that I should give. So you will get it by doing some literature review and note down these corners. So by logic, this line should lie on same point. That means y coordinate for this line will be same, 76.5. Note it down it using a pen and paper, guys. 13.5. So this point will be our, hence our y coordinate will be same here, that is 76.5, and this is 12.5, and this is once again 75.5 comma 12.5. So these are the coordinates that I will be giving in USGS. So now I am going to enter the same coordinates that I used here in USGS website. add coordinates. I am going to enter this. So 75.5 east. So this is x coordinate. The first point is x coordinate. It moves like this. So 77, 77.5, 76.5, 77.5. This moves like this. So this is x coordinate. So 77.5 matlab 75 degree 30 minutes. So 75 degree it's 30 minutes, and I would say 0. So it's north, sorry, it's easting, sorry, it's latitude it's asking. So 75 30 530, and this is 0. So you enter this, select east, and now comes uh, you have to have these four corners. So 13 degree, 30 and 0. So this is how you add 1 point. So it's actually in my state, home state Karnataka, the catchment I am trying to mimic. So next point will be add one more coordinate. So this is east. So I will be adding one by one, 76.5, 13.5. This is 76. So this is 30 and this is 0. So it's once again 13. So 30 and 0. They all come in same line. They should, that's how we have selected coordinates. Even if they don't come, no need to worry. You have to have rough approximate values. So longitude is 76, 30, 0. It's west. So now it's 12.5, sorry, 12 point 5 matlab 30 minutes add. So now add one more point, 12, 30, 0 east. So 75, 30, 0 add. So these are the this is where my watershed comes. So now I will leave it like that, data sets. So now comes digital elevation. I will select SRTM 1 arc second. So results, searching for results, and these are the things that I got. So you can see what is the footprint, how much these satellite images covers. So this four needs, I need to download all these four data. So once you have created your account, only then this icon will be available to download. So I will download all the four DMs. So one thing I would like to say is you have to be as organized as possible. um, I will create a folder in desktop and dump everything here. So I'm going to name it as tutorial because I'm teaching you all. So tutorial. So now I will download the raw DM data. So I will say a new folder, keep it as DEM. So uh, guys, you have to uh, download this and keep everything in this. So download everything, one geotiff download. So it takes time. Start downloading. So download everything. This geotiff you have to download, start download, minimize, slows, similarly download, start downloads. So once the download will continue, I will show how to prepare this DM. So download can take so much time if your net is slow. So but our college net is very fast. Let us wait for till it gets downloaded. So guys, everything has been downloaded. Now close it. So now as I have told you earlier, we have to be way more organized. So now go to this section where everything download. So see, these are the things that was downloaded. So cut this, and I have told you to be organized, so paste it here. So this is our DM. Now open QGIS. I need only QGIS for this. So now layer, add layer, so add raster layer, so select all the layers, desktop, tutorial, DM, so select all the layers and add them, open and close. Now these are four layers and you have to mosaic it. Mosaic is basically, to explain in one word, it is joining all the, it's like you when you were child and you were doing crafts, you remember pasting two things side by side. So mosaic is something similar. We are pasting all this one, two, three, four, taping it and pasting it, and this is called mosaicing. So we are doing that. So now we will be merging all these layers. It's easy. Go to raster and projections, I guess it's miscellaneous and merge. Select the input layers as all the four layers, and you will be joining it by side. So now select all. Okay, run this. So merge has been completed and you can see it here. You got already the merged file here. So this is the mosaic file. So I now what they have to do is reproject this into our UTM zone. So every watershed has its own UTM zone. You can see it easily here. You can type UTM zone for India. So by doing this, you can see this image. Click on images and you can find the UTM zone. See, currently that watershed I am working in is here in Karnataka. It's in UTM zone 43. So, but the UTM zone 43 and the UT and my Rispana river catchment that sir has given me currently is in Dehradun. It's UTM zone 44. For Kameng or Disang or tributary of Brahmaputra, this is the UTM zone, and for people of Andhra Pradesh, that Vamshavahini river, I think this will be the UTM zone 44. So now UTM zone 44, but now this Hemavati catchment is in the catchment that I'm trying to do is in UTM zone 43. This is how you get it. So you go to projections and wrap. I'm going to take merged layer. It has automatically taken it. So this thing will be ESPG346 target CRS is our UTM zone. So remove this and here you can see, if you can type or else you can type the UTM zone 44, it will appear here, then select it. So I have to select this UGS 40 UTM zone 43 north, because in northern hemisphere, and so let it be default reprojected. I will save it here as desktop tutorial. I will save it as repro dm. Name things like me only, so that you will not get confused. Name it as I am naming them. So I am running that. So see, the algorithm has run and it has been finished. So close. So now I have the reprojected dm. Now what I have to do is fill its sinks by Wang and Leo. So now for filling things, you have to go to the search tab in the left hand corner. Go here and fill sinks and select Wang and Leo. Wang, and double click on it and it has automatically taken my reprojected DM. So uncheck everything and fill the DM. So select this save file to, I will call it as, it will be in SD80 file, remember it. So I will be calling it as filled repro DM. So name it like this because this DM has been reprojected and also filled. Save it like this only. So run. So it will take some time. So be patient with that. So now our filling sinks by Wang and Leo is over. You uncheck the layer. So this is filled DEM. After filling, you can see here. So this minus value became 0, and from 0 to 1873 it is. So now what you have to do is take Strahler order. Strahler Strahler order. It generates the river order. It has already taken filled reprojected DEM. So save to file. I will give it as Strahler order. So once that is over, save it, run. So it takes huge amount of time. Be patient once again. So I'm pausing my screen recorder here since it takes huge amount of time. So now you can see my algorithm has been run and it is finished. Now I will close it. I will uncheck it now. If I zoom in, you can see the river network has been generated. If this continuity is not been established, then there is something severely wrong with your DEM or the procedure that you have done. So now for further procedure, see guys, for me, since I am showing it for Hemavati catchment, I needed four of these layers. So, but for Rispana catchment that our Subhashisa sir gave us, I needed only one DEM, one panel of it, not four. And hence I skipped the operation of merging it or mosaicing it together. So be careful if you there can be n number of panels for someone. For example, I don't know if it's true or not. For example, for Kameng River, you might get some like one more panel here or one more panel here. So to encapture whole catchment. So remember, for me to encapture a whole of my catchment, I needed four panel. But for Rispana, I can show you here. I can show you here. I needed only I needed only one panel of DEM. So this is the case. So no, if you need only one panel, you can skip the mosaicing part. You can skip the mosaicing part of the project and you can directly go for reprojecting it and then fill signals by Wang and Leo and then Strahler order. So guys, for Hemavati catchment, this is the outlet. So or this is the outlet or dam. So how do I know this? Usually dam points are the taken as outlet points. So how I can make sure, see this is the dam. This is where my dam is, Hemavati Reservoir, or it's also called Gorur Dam. So this is the, I can show you by clicking on and off this layer. So see it here. I'm switching it on. So this is my outlet. So sometimes you might not have a dam, but you have to select your outlet point. For example, for me it was Rispana River. I will show you. Rispana rejuvenation. So how did I select my outlet? So I downloaded some PDF or literature review and take a pen and paper and write down these coordinates I am saying. So for example, for me, this point is my dam outlet. So I will this point is my dam outlet. I will not see this point. I will note it down. This point is my dam outlet. So control Z. So see this point. So I will mark its x and y coordinates. I'm This is roughly I'm showing. So it is somewhere between 78 degree and 78 degree 3 minutes. It's in middle of it. So my x coordinate of the dam outlet will be 78 degree 1.5 minutes. Now my y coordinate will be a little bit higher than this. So I will select uh, 30 degree 30 degree. It's 18 minutes and 15 minutes. I will say it's around 30 degrees 16 minutes. Write it down in pen and paper. You need it to uh, delineate your watershed. So now you can see the river order. What is the river order, or at the outlet point, what is the river order for me? by taking this identifier icon. Where is my identifier icon? um, so select this layer, so I have to select this and go to symbology, properties, symbology. Now I can select Strahler or its pseudo unique palettes and band one. So classify, uh, apply this. So this is my river, this is how it looks. Now take this and you can select here. So see, my river order at the outlet point is 11. It's the river order of 11. So now I would like to see, there are so many river networks here. I guess these are river order of one, and this will cluster up and make a mess of our DEM. So or our catchment. So what I would like to do is remove those things. Select, for doing that, select raster calculator and select Strahler order, and this greater than or equal to, select a number for it. So I want all the river orders above 5 or above 6. I guess I will give 5 here. So guys, this is how you do. Go to raster calculator, and once you do that, greater than or equal to, greater than or equal to 5, I am selecting this output layer as, I'm giving this wait a minute, I have to be very careful where I save this tutorials. I'm selecting it as river order 5 to 12. So 5 to 12, I will rename it and save it. So then I would so I had some wrong expressions here, it is correct now. When I run it, it will take some time, and see, this is what I get. So these are the river orders less than 5 vanishes, and this is the river network that I get. Once again, what you can do is go to properties and select unique pellets, classify it, and then give some other color. I would like blue color for it, and apply it. This I will give, like to give it, okay, apply. Okay, so this is our river. You can increase the thickness also, properties, and let me you can select the thickness also here, thickness of our lines. Guys, you have to develop channel network. You type it here, channel network. So once you get this channel network and drainage basin, I guess channel network and drainage basin, type it here. So click here and threshold 5. Deselect everything except channels. Except channels, deselect everything and select this. Save a file to give an appropriate name. Channel network. I will give this name and I will run this. Okay, it takes time, but run it. Guys, I did a mistake and it's wrong. I have to take fill reproductor DM. So I did this wrong, and now I will run it once again. uh, Now it will be correct. Okay, I will watch after the. Our channel network has been completed. Now I will close it. You can see it here. See, oh, my channel network has not been created. Once again, I will remove this layer. I will create it once again. So channel networks and drainage basins. I will select the filled reprojected DEM. I will remove everything. Um, Drainage basins, and I will leave only channels. Okay. So I will save it. Save the file as. So I will overlap this. Yes, I want to replace it. Run. So wait for some time. I had done mistakes. I had taken 5 to 12 layer. Instead of, I should have taken filled reprojected DM. It takes huge amount of time. Please be patient with it. Guys, everything has been run now. You can clearly see the new layer that has been created here. So I can go to styles or properties. It's a shapefile layer. I can increase the thickness. I will increase it for 2. Then apply. See, so this is our river network. So ये तो ज़्यादा ही thickness हो गया. So I had to do some points. That's all. 1 or 0.75 I give you that, and this is our river network. Now we will create a layer for this dam outlet. This is our outlet, or any outlet. You have to create a outlet layer. That you can do that by going layer, create a layer, new shapefile layer, and it's a point. It's outlet. I will name it as outlet. So I will select this, and I will select this in tutorials. So save. Now it's a geometry type, it's a point, and it's WGS zone 43 north. So okay. So now click on this layer, toggle editing. uh, Once toggle editing, click on this pencil icon. So sorry, toggle editing, click on this icon, add features. So now uh, by doing trial and error, adding this satellite image, so I will select this as my starting point. I will call it as id1. So now once this has been done, click on icon, save. So now open the attribute table. Its attribute table, I can click on pencil icon here. So I will create a new field calculator, new calculator. It's called x coordinate. I will call it as x coordinates. It's um, x underscore coordinate. So now I can find it. Go to geometry, select $x $x. So it gives returns the x coordinate of the point features. Now double click on it, and click on OK. Now we have got the x coordinate of the point. Similarly, you create a new field. I will type it as. So I did something wrong here. So I will once again x underscore coordinate. So I should have selected here float data type or decimal data type. I didn't do that. It's wrong, and hence this column is wrong. Please don't note it down. So I will select, double click it, and OK. So could not add a new field to the provider. So I don't know what's the problem is. We will discard this. So guys, I did something wrong here. Now x coordinate has been ready. Note it down with pen and paper. Now I will do the same thing with y coordinate. So I will write it y coordinate here, y coordinate. So please my coordinate. So now I will select, it's a decimal real number. Now geometry, and then it's y coordinate. Double click on it and press OK. Note these numbers with note these numbers in pen and paper. Please note it down. Now after this you type here upslope area command, upslop upslope area command. So now select this. Now um, target area is optional. So now select this outlet point. I haven't saved this, wait a minute. So let's save it. Now I will open upslope area, and now I have to give target x coordinate. That I can do. Open attribute table, select this, copy the cell content, minimize this, target x coordinate, paste it, and similarly do it. Open attribute table, copy the cell content, close it, give it here. And elevation data I will select filled reprojected DEM, and method I will select deterministic 8. Then upslope area I will select it as save file to. So this is my catchment shapefile. So shapefile of catchment is, I will say Hemavati catchment, or in your case it's Rispana catchment or Kameng catchment, or it's Vamshavahini catchment. Give something name like this and have to run it. Guys, it has been run, and you can see here upslope area. Our area has been delineated, and our we finally got our catchment here. So this is how you get your catchment shapefile, but our work is not done here yet. So since this has been done, you can polygonize this. Go to raster, miscellaneous extra projection, wait, analysis, conversion, raster to vector, do raster to vector. So now select the Hemavati catchment DM, band 1 DM number. Save this, save this as save this file as tutorial. I am saving it as Hema catchment, catchment. So this is my catchment shapefile. I will save it here. So only thing is to run. Can clearly see the changes here. My shapefile has been done. Now when I open the attribute table, I have to, what I have to do is see the what gets selected if I select here. So I have press delete or shift delete. A delete हो जाएगा. Only thing is that I have to delete this. Edit, toggle editing, delete this. So finally we got our catchment shapefile. So and hence I will save my edits. So once I uncheck everything, you can clearly see um, the shapefile that is of our catchment. So this is how you create your shapefile. Now what you have to do is, everything has been done. So see some YouTube video. Once the shapefile has been done, import this reprojected DM, filled reprojected DM, and clip it. I can show you this clip DM. You can use it for HECRAS modeling. So you can do that by typing clip option, clip, extract by mask, or let us see here, let us do something, raster miscellaneous, or extraction, clip raster by masking a layer. Okay, you can select here filled reprojected DM. So now I can select Hema catchment as my masking layer. Target CRS is the uh, my, select this, and its zone, zone 43. So now my source CRS, and it's also zone. So now let us not do anything. So I will select this, and so this is my Hema DM. I will save it as Hema DEM. So now this DM can be used for HECRAS and many other things. So I am running it. Process has been complete. See, our DM also has been generated. I can uncheck everything and see this is our DM, catchments DM. You can use this for HECRAS modeling. Okay, so you can use it for HECRAS modeling. This DM, note it down, name it, like in your case it will be Kameng DM or Vamshamahini DM or Rispana DM. So name it like this and use it for HECRAS.